Good morning, everyone. Today we are going to go with the revision part of computer network, and today we are going to cover Unit 1 introduction part and Unit 2 physical layer. So, majorly today we are focusing on Unit 1, that is introduction, and definitely if we are getting time, we will move with Unit 2 also. So, when it comes to the introduction part of computer network, the first thing is, what is computer network? So here we can say computer network is the process of connecting two or more computers or devices so that they can communicate, share resources and exchange data with each other. Okay, or else if I explain the concept more, we can say that obviously the thing is computer network means it is a system of interconnected devices. Okay, it is a connection of interconnected devices, as we said, connecting two or more computers or devices. So we can say it is a system of interconnected devices. Maybe we can say device can be computers, servers can be there, routers can be there, or any other hardware devices also can be considered. Okay, that communicate with each other to share resources and data. So these devices are connected by communication channels. Okay, so all the devices, we said it is interconnected or connected to or more computers or devices already we said. So these computers or these devices are connected by communication channels like cables, wireless connections or fiber optics, anything can be. Okay, and it allows them to exchange information. Okay, so in general if we say what is computer network, so the meaning is there in front of you, that is computer network is the process of connecting two or more computers or devices so that they can communicate, share resources and exchange data with each other. Or else, as we said just now, a computer network is a system of interconnected devices. It can be like such as computer, server, printer, router, etc. Any devices can be considered. Okay, that communicate with each other to share data and resources. Okay, now when we talk about computer network, some more important components are there when it comes to this particular term. Okay, so here first one already we said device. Okay, remember when it comes to computer network, the components, the first component is device or different nodes we can say. So the device or node, what is the meaning of that device or node? So the device in the network like computers, smartphones, printers, servers which send and receive data. Okay, so in the definition itself we said it is about the interconnection of devices. So that devices can also be known as nodes. Now the particular nodes may be that computers, smartphones, printers, servers, etc. Okay, now the next term, again we have already uh, discussed, or we just speak about like a transmission medium, right? We need a communication channel, so that communication channel can be we can say that are considered as transmission medium. So here transmission medium means the physical or wireless medium that carry the data such as copper wires, fiber opticals or Wi-Fi signals also. Okay. Then the third important component of this area is NIC, we can say hardware that allow device to connect the network. Hardware that allows device to connect to the network. Okay. Then after, again so many different more devices are there that manage and direct data traffic between the devices. Okay, for that purposes we can say switches are there, routers are there, hubs are there. Okay, so these all are, we can say these all are the devices that manage and direct data traffic between devices. Then after the important component which comes under computer network, we can say protocols. So protocol, already we know, it is a set of rules that determine how data is transmitted across network. The most common protocol is, obviously, again we know this concept, that is TCP IP, Transmission Control Protocol or Internet Protocol, which governs how data is sent and received over the internet. Okay, so again, if I summarize this portion, so the question is what is computer network? So this is actually very important topic. When it comes to the introductory part, we should know what we are learning, why we are learning, right? So that is very important. So when it comes to computer network, again I am telling, a computer network is a collection of interconnected devices that communicate with each other to share data and resources. And again, the major components which are related to computer network are devices or nodes, transmission medium, network interface card, switches, routers or hubs, and protocols. Okay, so these are the major components which are related to computer network. Now, when we talk about computer network, this question can come for 1 mark, also it can come for 3 marks. Okay, so if it is coming for 1 mark, then the answer is in front of you, what is computer network, and the definition is also there. So you can write this portion for 1 mark. If it is coming for 3 marks, remember you should add the components of computer network also. So already we have discussed here just now that the components of computer networks are nodes, transmission medium, network interface card, that device that manage and direct data traffic between the devices, that are switches, routers or hubs, and the protocols. Okay, so these many things you have to include when it comes to computer network for 3 marker. Now we'll move to the next portion, that is type of computer network. Types of computer network. So you can see that when it comes to the type, we can say you have seen that PAN, LAN, MAN, and WAN. These are we considered as majorly the types of computer network. If you search in internet, you may get so many other things also. You may get SAN, okay, you may get so many storage area network. SAN means storage area network, and so many others are also there. So just now, for the time being, when the question is related to what are the types of computer network, remember majorly there are four: personal area network, local area network, metropolitan area network, and wide area network. Again, the space which cover, okay, the space which cover by LAN, MAN, WAN or PAN, we can say, look here we have made a small, here I have kept one small table for that. Okay, and here whatever the images we kept here, it is from computer network textbook only, from Andrew S. Tannenbaum that we are referring. Okay, so from there only we took this metrics. Okay, so here we can say the 1 meter distance, okay, that can be considered for the personal area network. If it is 10 meter, 100 meter or 1 kilometer, we can say that it is local area network. If it is 10 kilometer, 10 kilometer, it can be considered as a city. Okay, right? So it is for metropolitan area network. If it is about that 100 or 1000, country or continent can be considered, which is wide area network. Obviously, if we cover the whole planet, means more than 1000 kilometers, right? So the whole planet, if we connecting, so that concept we say is that it is internet. It is internet, right? So here, these are the general things which is given, okay, in your textbook also. So when it comes to the first term, it is about what we are talking about, personal area network. You can see this image, right? And if the question is about types of computer network and explain it with diagram, Okay, the question is, what are the types of computer network? Explain it with diagram. So the first thing is, definitely you will draw this portion, okay, types of computer network, and you will add all these four things. Then after, definitely you have to add one more area when you are explaining individually the things. So first one is PAN, personal area network. If you are drawing this, done. This is also okay. So it is up to you how you are showing different personal area network. That means whatever we are using for the personal uses can be considered as personal area network. So here we can say a small network designed for personal devices. Again, I repeat, a small network designed for personal devices like smartphone, tablet, or laptop within a small area like a room or for a desk. Okay, so I am using now my laptop for the communication, or I am keeping the smartphone with me for any connectivity purposes, or else whatever the things, okay, for a personal purposes, whatever the things we are using, that all can be considered for personal area network. So here a PAN is a small short range network that enables communication between personal device for easy data exchange and device connectivity. Okay, now also it allows, just now we said, personal devices like computers, smartphones, tablets, keyboard, mouse, okay, mice or mouse, printers, and headset to communicate and share data wirelessly or through cables. Okay, so both the medium we can use for the communication, like wireless mode also, or else we can say the wired way also. Okay, so the common example when it comes to PAN, Bluetooth network connecting a mobile phone to headset, or PC to a mouse or keyboard. Okay, so I think this is very easy concept you to understand. PAN means personal, means personally whatever the devices we are using for the communication, that all can be considered as PAN. So a PAN is a small short range network that enables communication between personal devices for easy data exchange and device connectivity. Okay, or else in short, you can write a small network designed for personal device like smartphone, tablet, and laptop within a small area like a room or a desk. Okay, now moving to the next portion, we can say LAN connectivity. Okay, so LAN connectivity means, okay, here again you can consider the room size. So the same image I have kept here. Okay, so when we consider a room, building, or campus, all these multiple PAN will be considered, right? Multiple PAN makes a LAN, we can say like that, right? In a building, maybe if we are talking about our computer lab, okay, there are so many computers which are interconnected each other, right? So we can say that is about what local area network. Through local area network we have connected here. So a local area network is a privately owned network that operates within a small area like a home, office, or factories, or else we can say building, campus. Okay, room, building, or campus can be considered as LAN. It connects computers and electronic devices to share resources like, okay, printers, and exchange information. So when we are connecting our computer or electronic devices, okay, with the printer, means we are sharing some resources, right? So sharing some resources or exchanging some information. So for that purpose only we are using what? LAN. Now moving to the next area, types of LAN. So here wired and wireless, both type of LANs are available. So wired LAN, obviously what we are using nowadays in our computer lab can be considered as wired LAN. Copper wires or optical fibers are used for the transmission of data, And when it comes to WLAN, wireless local area network, we can say that it uses radio waves instead of cables for the communication. Okay, so again, when it comes to LAN, okay, again I'm repeating, when it comes to LAN, we can say that a LAN is a type of computer network that connects device within a small geographical area, such as we already said buildings can be there, a room can be there, campuses can be there, right? It allow computers and other devices to share data, resources, and internet connections effectively or efficiently. Okay, when it comes to the characteristics of LAN, okay, when it comes to the characteristics of LAN, we can say that limited area. Okay, it covers only small area. Obviously it provides high speed. Okay, then after just now we said it is a privately owned network. Okay, so usually owned or managed and maintained by a single organization or a individuals. Okay, then after we said there are two types of LANs, wired and wireless. So we can say by using Ethernet cables, or else we said copper wires or optical fibers are using for transmission, and wireless are also available. Then after, comparatively, LAN can be considered as low cost compared to WAN. Okay, compared to WAN. The next session is about WAN, or we can say MAN. So comparatively that it is less expensive, or it is cheaper to set up and maintain. Okay, and when it comes to the component, again, when it comes to the component of LAN, we can say already in when we were discussing about computer network, some components we have already discussed, that are computers and devices, okay, or else nodes are there. Then the another component is switch is also there, routers are also there, cables or wireless access points are also there, and NIC, network interface cards, are also there. So these are the components which are related to LAN also. Okay, now here, as we were discussing, again back to the point, types of LAN, wired LAN is there, wireless LAN is there. Somewhere we can say enterprise network is also there. Okay, so enterprise network means when LANs are used by companies. Okay, when the LANs are used by the companies or any enterprises, they are called enterprise network. So here majorly we are giving importance types of LAN. When there is a question like that, you can say that wired and wireless. Okay, wired and wireless. So enterprise I have kept here for your knowledge only. Like yes, if it is in a company or in an enterprise it is kept, we can say it is an enterprise network. Now wireless and wired, again the description importance are given there. Wireless means we can say that every computer has a radio, modem, and antenna to communicate wirelessly. Okay, uses an access point or wireless router to connect computer and relay packets to the internet. And the standard of this Wi-Fi or wireless LAN is IEEE 802.11 is the standard which is used for Wi-Fi or wireless LAN, and the speed we considered it as 11 Mbps to hundreds of Mbps. Now when it comes to LAN, the characteristics are wired LAN. Obviously it use copper wires or fiber optics, right? And then we can say have limited size or transmission delay is also predicted in this area. Now the typical speed is 100 Mbps to 1 Mbps. Newer LAN up to 10 Gbps, gigabytes per second, gigabits per second. Now also it offers low delay and very few errors, better performance than wireless network. Always remember that wired and wireless, the difference when it comes to this area, we can say wired always give better performance than wireless. Okay, this is very important you to remember. So here we can say the functions. Again, the functions, if we talk functions of LAN, so whatever we have discussed, okay, we said what is LAN, what are the types of LAN, and then after we give importance to wired and wireless LAN characteristics also. So if we revise all this point, from that if we talk the functions of LAN, we can say yes, majorly it is used for what, file sharing. Second thing, we can say it is actually for resource sharing. Third, we can say communication. Fourth, we can say centralized data management, right? So these all are the different functions. Okay. Now, if we talk about the example, okay, example for LAN, so already the information is there in front of you. You can give example like covering a room, or the coverage of campus, or a coverage of a building can be considered as a LAN, right? A computer lab can be considered, office network can be considered, or else we can say home network can be considered in this part. Okay. Now, so here, moving to the next portion, that is WAN. Okay, the next portion is WAN. Sorry, the next portion is MAN, Metropolitan Area Network. So the first one was PAN, second is LAN, third one is MAN, Metropolitan Area Network. So here we can say multiple LANs can make a MAN. We can say like that, right? Because when it comes to LAN, room, building and campuses are connected here. So here multiple campuses, multiple buildings. Okay, if we connect that, we can say that we are covering here a city, right? We are covering city. Okay. Now, so MAN means, we can say, Metropolitan Area Network. It is a type of computer network that spans or that cover a metropolitan area, or such as city or large campuses. It connects multiple LAN to form a larger network, enabling high-speed data communication over a geographic area larger than LAN but smaller than WAN. Okay, smaller than WAN. So larger area for LAN and smaller than WAN can be considered as metropolitan. So sorry. So here MAN are designed to provide efficient and reliable connectivity for data, video and audio transfer between different LAN within a city or metropolitan region. They typically use fiber optic cables or other high speed medium to ensure fast communication. So here, when it comes to MAN, again I'm telling, please note down the points. It's very important. Exam point of view, we are discussing all this concept here. Okay. So MAN means Metropolitan Area Network. It is more than LAN and less than WAN. Okay, the area which it covers more than LAN and less than WAN. We can say city or large campus can be covered in this portion, and it connects multiple local area networks to form a large network. Also it provides high speed data communication. Now the advantages, we can say it provides centralized management for easier monitoring and control of network resources. Also, it ensures high speed internet access and support multiple users simultaneously, and facilities like resource sharing and data exchange between internet LAN connected. Okay. Now, next we can move to the next session, that is WAN. Okay. So WAN means obviously it provides the large geographical area such as country or continent, we already said. It connects or office multiple lands or offices located far apart. Again, components of WAN, we can say transmission lines or switching elements are there. Switching elements can be considered as switches or routers. Okay, that is a switching element. Then after, a WAN mainly consists of two parts. Okay, so here transmission line can be, we can say that carrying or it carries bits from one machine to another. And obviously when it comes to transmission line, we can say made up of copper wires, optical fibers or radio links, usually leased from telecommunication companies. Okay, so that is about WAN. And a part of, as we are talking about, the WAN majorly consists of what, two parts from one is transmission line and another one is switching element. So this transmission line can be leased from telecommunication companies. Okay, now when it comes to switching element, special computers that connect multiple transmission lines. Second point is when data arrives, they decide with which outgoing lines to send it on, and commonly it is called routers also. Okay, so remember, if you don't remember all this point, still I request everyone to remember minimum that our WAN area, WAN means wide area network that covers a large geographical area such as country or continent. Second important part that you have to remember is, we can say it connects multiple LAN, local area network or offices located far apart. Okay, and we can say it is actually slower in speed. We can consider that also slower in speed, because LAN was connected in a building or in a room or in a campus. Okay, when it comes to metropolitan, that is also about the city, but WAN, it actually connects country or continent. We said it is covering a large geographical area. So comparatively, LAN or WAN, we can say it is actually providing you slower speed. Okay, then after, it is again we can say that it is very difficult to set up a WAN connectivity. Okay, because again it is covering the large area, or also we can say it requires routers, leased lines and other advanced networking equipment to connect. Okay, for the connection purpose. Okay, so these are the major things that you have to remember on this area. Okay, so if we summarize the points what we have learned in WAN, okay, what we have discussed in WAN. So the first function that comes in our mind is what? It connects. It connects what? Offices or different branches of a company. Okay, it connects remote offices or branches of companies. Again, the second point which comes to our mind is global communication is possible. Global communication is possible. Third, we said that support data across data exchange across long distance. It supports data exchange across long distance. And the final thing we can summarize here is, it facilitates centralized data management. Okay, so these are the important points when it comes to WAN. Okay, when it comes to WAN. So again I repeat, here a WAN is a, what is a network? It is a network that extends over a large area, enabling computers and devices in distance locations to communicate and share data. Okay, and remember, this is very important question when it comes to introduction or unit number 1. Again I repeat, what are the types of computer network? Explain it with diagram. Okay, explain it with diagram. So explain it with diagram means you have to actually go through with all the images which we have kept here. Okay, So here types of computer network: PAN, personal area network; LAN, local area network; MAN, metropolitan area network; WAN, wide area network; and obviously the last thing is internet. Okay, interconnection of network, we can say interconnection of network. So that is internet, right? So we are moving to the next area, that is, okay, before that, okay, as we were talking about internet, the last concept is internet or interconnection of network, that we are keeping a little bit hold. Before that, we are moving to another area, that are different uses of computer network. As we said, these all are the computer networks. Okay, LAN is a network, WAN is a network, MAN is a network. Okay, so means whatever the devices we are connecting for exchanging data or information, that all are considered as different type of computer networks, right? So what are the uses of these different networks? So first thing is resource sharing, right? Second is data and file sharing. Third, we can say centralized data management. Fourth is communication. Then after e-commerce, then after remote work, then after we can say backup and security, internet sharing or social networking purposes we are using, entertainment purpose also we are using computer network, smart home devices, file and printer sharing, online education and work, location based services like GPS. Okay, or else we can say IoT and wearables. For that area also we are using computer network concept. Okay, I think this is very clear for everyone, that different areas where we are using computer network, or we are using the help of computer network. Okay, or we can say the use of network also, right? So here resource sharing is very important, right? So one by one, okay, I'm giving 5 10 seconds to you. Please go through resource sharing till IoT and wearables. If you have any doubt, you can message me, you can ask me, but please go through the portions. Okay, we are moving to the next portion. Okay, I hope you people doesn't have any doubts till this area. Okay, if you have any doubt, please put in a chat or please message me so that we can discuss on that portion also. Okay, now we were talking about internet or internet working. Okay, this is again an important portion. Internetworking refers to a practice of connecting different computer networks or network segments to create a large and more extensive network infrastructure. This process involves using various networking technologies, protocols, and devices such as routers and switches to enable communication and data exchange. Okay, so the first thing is about what is internetworking. What is internetworking or what is internet? So here we can say internetworking. It is internet term. If we consider internet, Okay, inter and net, interconnection of network, we can say interconnection of network. So here, internetworking is a practice of interconnecting multiple computers, and typically it is giving importance to what, to connect for the connections and connection of networks to exchange messages. Okay, to exchange the messages. Okay, and the next thing we can say, as we said, interconnected network, it is also known as internetwork, or we can say it is also known as internet. Okay, is it clear? So if the question comes, what is internet, so you know that internet working is also a term which we are using. Internet also a term which we use to speak about internet. Okay, so it is an interconnection of network. In short, we can say it is an interconnection of network. Okay, so the meaning of internet also, inter also, you know, maybe inter means between the network, right, between the networking. Okay, now internetwork refers to the practice of connecting multiple computer networks together to create a large global network of networks. The primary goal of internet working is to enable communication and data exchange between devices and user located on different networks. So the primary goal of internet work, what is the primary goal? To enable communication and data exchange. Okay. Okay, so here we can say that the primary goal of internet working is to enable the communication and exchange the data between the devices and user located on a different network. Okay, it is not compulsory that we are in a same network, maybe in a different network, maybe in a different place or different location. Okay, so we can say to enable that communication and also to exchange the information between the devices, that is internetworking. Internetworking is made possible through the use of various networking technologies and protocols that facilitates data transmission across heterogeneous networking. Okay, so we can say that heterogeneous, you know the meaning of heterogeneous? We can say heterogeneous means diverse. Okay, diverse, multiple, varied, or various. Okay, so here various networks, transmission, data transmission across various networks. So internetworking is made possible through the use of various networking technology and protocols that facilitates data transmission across different networks or various networks. Okay, the internet is the most prominent example of global internet work, with which interconnect millions of networks worldwide. So here, remember, this question can be coming for one marker or something only. Okay, so one marker question if it is coming, remember what is internet work. What is internet working? We can say internet working refers to the practice of connecting different computer networks or network segments to create a large and more extensive network infrastructure. Okay, second point, these process, which process? The connectivity or the segment which we are creating or for the connection purpose. For these process involves various network technologies, protocols, devices, and which kind of, what kind of devices? Routers can be there, switch can be there, hubs can be there, right, to enable communication and data exchange between distinct network. Okay, so here internetworking, again I am telling, this is also known as internetwork, internet. Okay, moving to the next, again ARPANET and NSFNet, these two networks we can using initial stages before internet came to an existence, we can say these two were used. So the first one is ARPANET. ARPANET means Advanced Research Projects Agency Network. Remember, these questions are also coming for 1 marker or 3 marker. Okay, I haven't seen this comes for 7 mark, but yes, this is also a very good question which can become for 7. Okay, like what is internet? Also explain about ARPANET and NSF net can be considered. Okay, so remember this is very important, very good question. So ARPANET means Advanced Research Project Agency Network. So ARPANET was the first computer network that connect different computers to share information. So why we are using computers or why we need this connectivity? Definitely the answer is to share the information, right? To share the information, to communication, or whatever the needs we saw, the uses of computer network, that all can be considered, right? So here ARPANET was the first computer network that connected different computers to share information. It started in 1969. It started in 1969 by a US government agency called ARPA, Advanced Research Project Agency, ARPA. Okay, so what working or what was the concept behind ARPANET? We can say ARPANET broke information into small pieces called packets, and then it sent them via multiple possible routes to reach the receiver. Like we are choosing the different road to get to the same place. Okay, they were actually they were they were what we can say, making it in a smaller pieces like packets, and then they are sending the information. Okay, so now the next important point on this area is it used devices called IMPs, or we can say routers, to help send the information between the computers. ARPANET helps scientists and researchers to share data and communicate easily. It was the beginning of what we call now the internet. Okay, so here we can say that ARPANET was the first computer network which comes to an existence, or which was started in 1969, and it was developed by US government. Okay, it was developed by US government agency which was called ARPA, ARPA, Advanced Research Project. Okay, and the major concept behind this ARPANET was to brokenize the information into smaller pieces called packets, and then send it to the possible ways, okay, to the receiver. Okay, and for this purpose it helped the sender to send information between the computers, and this was very helpful that time, or that was very great invention. So we can say that it helped scientists and researchers also to share the data and communicate easily. Okay, and it was the beginning of what we call now internet. Okay, next, moving to the next area, we can say that NSF net, National Science Foundation Network. National Science Foundation Network. So NSF net was created in 1980s. It was created in 1980s to connect bigger research centers and universities. It acts like a high-speed highway for data between many smaller networks. It was providing high speed. In short, it was providing high speed. NSF net helped the internet grow beyond military and research lab to colleges and eventually to the public also. Okay. So here the very important point that you have to remember is ARPANET, generally it was made, or this was invented for the purpose of military. Okay, for the security purpose it was made, so military purpose and for the research labs only. But what happened when the NSF net came in 1980s, it was created for public. We start using internet service from 1980s, we can say. Okay, it made easier for more people to use and access the internet, right? So here, when it comes to the, again, we are moving to the next portion only. Before that, we are just summarizing what we learn. Okay, so the first thing is internet or internet working. So internet, that concept, okay, this was came like interconnection of network. Okay, interconnection of network, from that term it came internet work or internet working. Okay, and the history, if we talk about the history of this internet working service or internet, we can say 1960s or 1969, proper date if we talk, 1969 ARPANET was invented. Okay, and in 1980s we can say this NSF net came. Okay, and as NSF net give importance to the public accessibility of this internet services, we can say, if we can give one more, we can add one more information to this portion. That is, in 1991, Tim Berners-Lee, okay, he actually introduced the concept of WWW, that is World Wide Web, which made the internet easier to use with websites and browsers also. Okay, so remember all this point. The invention was started on 1960s, then it comes to 1980s. Okay, for the public accessibility area. Then after, we can say in 1990s or 1991 onwards, we are giving importance, or we are using it more efficient way from 1991 because of Tim Berners-Lee. He introduced WWW, World Wide Web. Okay, fine. So we are moving to the next portion. Now again, internet architecture. Okay, so I'm again giving 10 seconds to everyone to summarize what we learned or what was the concept we were trying to understand here. Okay, so please 10 seconds, take 10 seconds, make a small point. If you have any doubt, please ask so that we can discuss on that area. Okay, now moving to the next important point, that is what is internet architecture or what can be considered as internet architecture, right? So here we can say the internet architecture is a structure, right? It is a structure that show how different networks and devices are connected and communicated with each other. After all, the use of network, we can say the use of network is majorly focused on how to connect with each other, how to connect or how to communicate with each other, how to share the resources with each other, right? So here we can say the internet architecture is also structured in such a form that shows how different networks and devices are connected and communicate with each other. It is based on different layers, which is our next topic. Okay, so each layers like here one we can say OSI models or TCP/IP models are there, which actually communicating through the layers. Okay, so that point we can discuss in coming session or coming next area. Okay, so here the internet is made up of many different network connected together using common rules called protocol. Okay, so the starting itself we said it is to communicate or to share or to exchange information, and it should have some particular structure, right? So the here the internet is made up of many different networks that connect together using common rules. So the rules are known as protocols. It is designed, again we are in the same point, that it is designed to send data in small packets. Already we said the small packet concept starts from where? From the ARPANET area only. 1960s it was started. That can travel different paths to reach the same destination. The system is decentralized, means what? Meaning no single computer controls the whole network. Okay, it was decentralized, meaning no single computer control the whole network. These design make the internet very strong and able to keep working even if parts fail. So internet allow many services like email, websites and file sharing. Also, and also we can say all this based on original idea from ARPANET and NSFNet. So remember, this is very important you to understand the history of internet. So ARPANET was the first internet connectivity which we were using for military purposes or for the security communication, security type of communications. Okay, so ARPANET was there. Then after NSFNet came, which was actually giving importance for public interest also, or we can say the internet should open for public also. That concept came from NSFNet, and it was widely used from 1990s, we can say, as Tim Berners-Lee has come up with the invention of WWW. Okay, so this is again an important area. Now as we were talking about the structure, that show how different network and devices are connected and communicated with each other. So here we said certain type of protocols are there. Then we said small packets are there. Then after we said decentralized methods are there. Then after we said that internet design makes the internet very strong, okay, to keep working even if any part fails. And also these all services, right? So different layers are there, or different structures are there for all these things. So again, very important part is protocol layering. Protocol layering part is there. So protocol, already we said, it is a set of rules. It is a set of rules, and in that area itself we said that that different layers are there for all this communication. To communicate properly, different layers are there, right? Okay, so here protocol layering is design approach used in computer network where the complex task of communication is divided into smaller manageable parts called layers. So here remember, the question you can expect here is, what is protocol layering? What is protocol layering? So you have to remember why this protocol layering is important. Okay, so the major thing is what we said, that internet architecture is the structure. Okay, it is a structure that shows how different networks and devices are connected and communicate with each other, and it is based on layers, each having specific functions. So it is based on the layers. So that is the reason that we can say this protocol layering is very important us to understand. Okay, like through which all layers the information passes and finally reach to the destination. Sender is sending some information and the receiver is getting the information. So we are actually we maybe don't know how this function works, right? So here we are getting a clear idea by going through this protocol. By going through this protocol layers, we will come to know that how effectively the sender receiver informations are um, going on. Okay, how the sender sending information to the receiver, or how the receiver get informations properly, right? So here the first thing is protocol layer is designed approach. It is a design approach used in computer network where the complex task of communication is divided into smaller manageable parts. Okay, manageable parts called layers. So these smaller and manageable parts are called what? Layers. Each layer performs a specific function. So here you can see OSI model and TCP IP protocol architecture layer. Both are having different layers. Okay, so these all layers perform specific functions and communicate with the layers directly above and below through well-defined interfaces. So if sender is there, okay, if information is sent, okay, so it comes to application layer, then presentation, then session, then transport, then network, then after data link, then after the physical layer. And now when it comes to the receiver end, first it comes to physical, then after data link, then network, then transport, then session, then presentation, and finally reach to application layer. Okay, so here the communication is happening from application through the all the below all the layers, then after moving to the next part. Okay, so each layer performs a specific function and communicate with the layer directly above and below it through well-defined interfaces. This structure help to organize network protocol and make network easy to design, implement, and manageable. So when we talk all these layers, when it comes to OSI model or a TCP IP model, in every layers there are certain protocols, okay, which does the particular functions, or which is actually assigned for that particular functions only. Okay, so we will come to know what kind of protocols are used in each layers to perform certain actions. Okay, so protocol layer, again I am reminding, protocol layer is a design approach used in computer network where the complex task of communication is divided into smaller manageable part called layers. Each layer perform a specific function and communicate with the layers directly above and below it through well-defined interface. This structure help to organize network protocol and make network easier to design, implement, and manage. Okay, moving to the next portion. So here, if we talk about again protocol layer, as I said, it may come for 1 mark also, it may come for 3 mark also. So you should know what is protocol layer and how it functions, or why it is very needed, why it is important, right? So here protocol layer, we can say it divide communication into layers such as already the layers we saw. In OSI model it was 7 layers. In TCP model we saw 4 models, right? So each layer handles a particular aspects of communication. Okay, each layer handles a particular aspects of communication process. Layer interact only with their immediate neighbor. Okay, it actually communicate with the next neighbor. Means if I talk about, if here we talk about application layer, it communicate with presentation, it may have communication with session layer or application layer. If we talk about transport, it may have communication with session or network. Okay, so this is what we mean the immediate neighbor, the next neighbor, right? So here data is passed down from one layer to the next during sending and passed up during receiving. So this is also an important concept. When we are into the sender part, data moves from up to down, and when we are in a receiving end, it comes to down to up. Okay, this is the approach. Now this approach allows different protocol to be used at different layer, enabling flexibility and interoperability. Okay, so here we can say that it moves from up to down or down to up. So this is actually very important when it comes to the part of interacting with different layers. or when it comes to the part of flexibility and interoperability. So again we are talking that here 7 layers in OSI, and TCP it has 4 layers. Okay, somewhere you can see that 5 layer, but majorly if we focuses, there are only 4 layers according to computer network textbook also. Okay, which I am preferring Andreas Tannenbaum's textbook. In that also you can see the 4 layers. Okay, so the next area. Okay, next area. So here we are talking about protocol layer. So these are the layers. Okay, 4 layers, and here 7 layers. Already the importance of or the meaning of layer also we discussed here. Okay, and why it is needed, that also we have discussed. Then after, these are the important points when it comes to protocol layering. Now the important topic comes to the computer network is connection oriented service and connection less service. Connection oriented and connection less service. So when this term comes to our mind, this term come to our mind, we can say that when it comes to connection oriented, first thing comes to our mind is TCP. When it comes to connection less, we are considering as UDP. Already this we have discussed in our lectures also, right? So maybe when we are talking about connection oriented and connection less, these two terms comes very fast to our mind, right? So connection is established between sender and receiver before any data is sent, similar to making a phone call where the line is connected first. So connection oriented says that before we think to make a phone call, very important thing is what? It should connected. It should connected with rather than, actually, if I don't have internet connection in my phone, or we can say if there is no balance in my phone, how can I make communication, right? So that is very important. Or if there is no network, or my SIM card is not activated, so that all can be considered as a connection part. That all can be considered as a connection part. So a connection is established between the sender and receiver before any data is sent, similar to making a phone call where line is connected first. Data packets are sent in order. Again, this is very important. Packets are sent in a order when it comes to connection oriented service. Okay, packets are sent in order, and the connection stays active until all data is successfully transmitted. Okay, then after, this service ensures reliability by detecting errors, acknowledging received data, and transmitting lost packets. Okay, so this is again a very important area when it comes to connection oriented, that it is providing or it is ensuring that the other party should receive reliable information. Okay, the other party should receive reliable information, and it obviously check the errors. It will check whether any errors are there or not. Then obviously when it reaches to the receiver also have some responsibility, right? He should acknowledge, he should give the feedback that yes, I received the message, right? So that acknowledgement is also possible when it comes to connection oriented. And while transmitting data, if due to any reason, if data packet losses, what happened, it will retransmit the lost packets also. Okay, and it requires more resources and time to set up the connection, but guarantees data delivery without loss or duplication. So here, connection oriented, it requires what? More resources and time to set up, because it is connection oriented. That the connection is or the communication is happening because of wired medium, we can say wired medium. Okay, so that is the reason it need more resources, and it need time to set up. And the thing is, obviously it takes much time, but the thing is, if it is wired communication or if it is a connection oriented service, we can say we are getting a guaranteed data delivery without loss or duplication. Okay, So remember the points here when it comes to connection oriented. Again, remember here the major thing is a connection is established between the sender and receiver before any data is sent. Before any data is sent. Second thing we have to remember, data packets are sent in order. Sent in order. This is again an important point. Okay, the first point is before any data is sent. Second point is sent in order. Third point, we can say it ensures reliability. How it is ensuring the reliability? By detecting the error, acknowledging the receiver's data, and retransmitting if it is needed, means if any loss of packets are there. Then the example for connection oriented services, TCP, transmission control protocol. And obviously here we, from starting onwards, we are discussing that as it is a connection oriented, it may take time for setup, or it may need more resources, but it is actually giving guaranteed data delivery without a loss or duplications. Now, whatever the things we discussed on this area, maximum things are what reverse. Maximum things comes to reverse in this portion. Okay, like we can say, no connection is set up before data is sent. Data packets are sent independently, like sending letters through a postal system. So here, no need of what? Any connections, no need of any connection setup. Okay, before sending the data. Here it was very important before sending the data. Now, each packet can take a different path and may arrive whatever the information we are sending, it may take any different path and arrive in any order. And there are chances that whatever the path they have opted may have some network issue. Because of that, the data was lost. There is no guarantee of delivery, where here it was, it ensures the reliability. It is not providing any guarantee that the information that we have sent will received by the receiver. Okay, and there is no guarantee of delivery. Acknowledgement or error corrections make this faster but less reliable, as there is no guarantee for the delivery, there is no acknowledgement, or there are less chance of error corrections. Okay, these are the things which make it faster comparatively. Connection oriented, the information will reach very fast but not reliable. But it will be not reliable because all the packets are not received at the end. Maybe there are chances that some packets may lose and you are getting partial information. Okay, then after, when it comes to UDP, user datagram protocol, we can say it is again, here it is TCP, and the protocol which is activated here is UDP. Here, because of TCP, we are getting the reliable communication. Here it is a UDP, because of that only the information get lost. Okay, so here it is used for video streaming, online gaming, voice call, etc. This UDP is getting activated. And here it is about web browsing, email and file transfer. We are using TCP. It uses fewer resources and has lower delay, but may face congestion and packet loss. Here it actually needed what? Few resources and has lower delay. Okay, the information may reach very fast, but the problem is what? There are actually lot of congestions, network congestions or packet loss can happen in this area. So remember both or compare both the sessions. Again, this is very important. You can you can think this question for 3 mark. I don't feel that it will come for 7 mark, but yes, you can expect 1 or 3 mark from this portion. Okay, we are moving to the next area, that is service primitive. Again, this is very important. It can come for 3 or 7 marks. Service primitive, which is again very important one. Service primitives are basic operations or functions provided by one layer of network protocol to the layer above it to enable communication and cooperation between adjacent layers. Okay, So when we were discussing about protocol layering, okay, when we were discussing about protocol layering, OSI model, you have seen that there are 7 different layers. Okay, in so the 7 layers, how it was communicating, we can say that if it is about the sender point of view, the information pass on from up to down, and if it is about the receiver point of view, down to up. Okay, and obviously there are some adjacent communication is also happening between these layers. Okay, so this is actually, we can say this actually about the service primitives or the basic operations or functions of each layers, because of that reason only. Now, how it is possible, or again I'm repeating, service primitives are basic operations or functions provided by one layer of network protocol to the layer above to enable communication and cooperation between adjacent layers. They define how a layer can request or respond to the service, conveying control information or data between the layers. Okay, so there are so many service primitives. Okay, when it comes to the sender or receiver part, we can say there are so many service primitives for these purposes. So the first one is, we can say, request. Okay, request. So send from an upper layer to the lower layer. Okay, as we said, if it is a sender point of view, up to down communication is possible, and the receiver point of view, down to up is the possibility, right? So here request means the send from the request, always send from where, up to down, right? Because application layer is the first layer where the users are interacting, right? The users are interacting. So send from an upper layer to the lower layer to request a specific service or action. Then after, there will be an indication. Indication means send from a lower layer to an upper layer to inform that an event has occurred. Okay, or incoming connection or data arrival. Indication means, yes, I got the message, now I am sending back it to you, right? So response, send from an upper layer to the lower layer to an indication. Okay, the response happens from upper layer to lower layer to respond. Okay, and this response is from where? From the indication. From there only you are going to get the response. So accepting a connection or rejecting it. So the response means, okay, indication says that I'm getting some information from the lower to an append has occurred. And when it comes to response part, we can say that it is responding whether the connection was accepted or rejected. Okay, the connection was accepted or rejected. And the final one is confirmation. So confirm means send from lower to an upper layer to confirm the result of previous request. So whatever the request was sent from the sender to upper to lower, okay, it is actually comes to the indication. It is based on the response, and finally it will confirm. If the response is accepted, we can say accordingly it will confirm that yes, connection successfully established or the data was sent. Okay, I think this portion is very clear for everyone. Again, service primitive remembered, and the types of service primitives are request, indication, response, and confirm. Okay, response and confirm. There are 4 service primitives. Okay, now functions in layered architecture. Okay, functions in layered architecture. So this already we have discussed prior only, what is layered architecture. So some more points we have add on here. Primitives are calling functions. Okay, so primitives are the calling function between layers within the same device. So whatever the functions we are calling, that all are considered as primitives, right? And they manage communication among adjacent protocols. So here when we talk about OSI model, from topmost layer to the down layer, total 7 layers are there. And in the receiver end also there are 7 layers. Okay. So in between, we can say the sender and receiver. When the sender is sending an information to the receiver, we can say between all the layers, we can say there are some adjacent communications are also happening, or adjacent protocols are also there, which actually communicate the informations properly. Okay. Now, the third point is the specific set of primitives depends on the service type. Yes, the specific set of primitives. Again, primitive we said calling functions are that, and this is actually these services are based on, depends on the connection oriented or connection less. Okay. Now, so here we have just added one small example. Okay, connection oriented and connectionless. Connection oriented, we already know, listen to the server, establish the connection, accept the incoming connection, send the data to the peer group, receive the blocking or blocks waiting to receive the data, and disconnect once the communication is done. And connectionless, unit data, facility, and report. These are the things which are there in connectionless services. These are the services which is there in connectionless. So unit data means send a data packet without establishing a connection. Report or facility, it is actually request performance report or delivery statuses. Okay. Moving to the next area, again we were talking about what service primitives. Okay, so service primitive, when we discussed that portion, we said that it is a basic operation or functions provided by one layer of network protocol to the other layer above it, right, to enable the communication, okay, and cooperation between the adjacent layer. And we said that it is a calling function also, it is a calling function, and also it manages the communication between adjacent protocol layer, right. And the specific set of primitives are dependent on the service type. So these are the points which we discuss for services or service primitives. So again when it comes to the service, we can say what service means. What? Reliable delivery of data. It means reliable delivery of data, and how this reliable delivery of data is possible, so that we can say TCP defines how acknowledgement, sequence, and transmissions are done. Again, this is very important when you are discussing about services or protocols. This is very important you to draw, okay, the different layers, how it actually communicate through a protocol. That is very important. Okay, so here in computer network, services and protocols are two closely related but distinct concept used to define communication, right. Service is different, protocol is different. Okay, you can see that both are closely related, but both are different. Both are different because service is giving the question or giving answer to the question what, and protocol is giving the answer of how. Okay, so both are different. So here they are essential in layered models such as OSI model and TCP IP model. So here a service is a set of operation that layer protocol layer provides. A set service is a set of operations that a layer provides to the layer above it. It defines what the layer does, not how it is done. Okay, so this is very important you to remember. Service defines what layer does, not how it is done. The service hides the details of its internal working and provide a clean interface to higher layer. So it service hide the details. Okay, it will hide the details of internal working and provide a clear interface to higher layer. So here the example is transport layer provides services such as reliable data transfer or connection oriented service to the application layer. Okay, so this is actually about what the layers does, but not how it was done, how the transport layer is providing reliable or reliable data transfer or connection oriented communication to the application layer. So the how is not there, but what the layer does, that is what happening in service. When it comes to protocol, again remember, it is a set of rules and conventions used by the entity or the peer in the same layer on different machines to communicate. Okay, it defines how the service is implemented. How the service is implemented. Remember what layer does and how the service is implemented. Protocols are responsible for data formatting, transmission, and different and protocols are responsible for data formatting, transmission, and control between communicating system. Okay. So here the example is TCP, Transmission Control Protocol, is the protocol that implement the reliable data transfer service offered by the transport layer. So above example what we said, the transport layer is providing the service, okay, such as reliable data can transfer or connection oriented communication to the application layer. Now this area we are actually talking about the TCP is the protocol that implement the reliable data transfer, okay, that the transfer service offered by the transport layer. Okay, so I think till this portion it is very clear for everyone. If there is any doubt you can message me or you can ask so that we can discuss on that area. Okay, moving to the next portion, it is very important and I think this is the second last or last topic of this unit. Okay, so OSI model, total 7 layers are there. There are 2 layers, one is media layer and host layer. In media layer you can say physical, data link and network layers are there, and when it comes to host layer you can say transport, session, presentation and application layers are there. Okay, the way it interact. Okay, so the physical means obviously it is a wired or wireless connections we can consider. It is in the form of bits, binary numbers, okay, binary digits you can say. So by in the form of binary zeros and ones, then after it moves to a frame, then it moves to packets, then when it reaches to transport it comes to a segments, and here onwards it start in the form of data. Okay, and here we can say the TCP IP model, 4 models are there: network interface layer, internet layer, transport layer and application layer. So here the application layer, the layer number 4, here the application layer. So in TCP IP, presentation and session layers work is also done by application layer. Okay, application layer is doing the work of presentation and session when it comes to TCP IP. Then after transport layer, internet layer, that is network layer, that is network layer, and network interface layer, that is physical and data link layer activity is done in network interface layer. Okay, so again I repeat, application layer is doing the job of presentation and session in TCP IP. Transport layer, both are common only. Internet layer, it is actually doing the work of network layer. And network interface layer, we can say data link and physical layer information is done in network layer. Okay, so the first one is OSI model, very important question which you can expect in your exam. OSI model. So OSI reference model was developed by International Organization for Standard, ISO, in 1984. Okay, in 1984, it provides a standard framework for how data is transmitted over a network. So it is a standard framework. Already we learned in internet architecture also that it has some standard framework. Okay, and that is also actually transferring information by using protocol layers, or there are some protocol layers which because of that only it was interacting properly. So here we can say it provides a standard framework for how data is transmitted over a network. And the main goal of OSI model is to guide, protect developers and promote interoperability between different systems and networks. So this is the main goal of OSI model, that it guides, protect developers and promotes interoperability between different systems and networks. Okay, so the objectives of OSI model are, the first one is to standardized network communication function, to standardize network communication function, to ensure interoperability between different vendors and technologies, to divide complex network communication in smaller manageable layers, to allow troubleshooting and update to be handled per layer. So here the first thing is, again, actually we were discussing OSI so long, no? Initially also we said OSI TCP IP. So just again, what is the full form of OSI? Okay, so the OSI stands for Open System Interconnection. Okay, Open Systems Interconnection Model. OSI model means Open System Interconnection Model. Okay, and one more term we were discussing here so long, that is interoperability. Do you know the meaning of interoperability? Interoperability means the ability of different system devices or software to work together. Okay, to work together. So that is the meaning of interoperability. Okay. So here these four are the major objectives, means standardize the network communication function. So standardizing network communication means different protocols are there, different layers are there. Accordingly, it will be standardized. To ensure the interoperability means the interconnection, or at the same time the information can be moved from one part to another, that is interoperability, right? Or the smooth functioning of the data at the same time can be considered with different vendors and technologies. To divide the complex network, that complex network communication can be brokenized into smaller parts and in a manageable layers, and also to allow the troubleshoots and update to handle per layer. Are we can say, if we brokenize the communication and it is passed to the, so what the layers are doing, it is moving, uh, um, it is moving to the another layer, right? Maybe if it is about the sender to receiver or receiver to sender, if it is sender to receiver, we can say that the one layer is giving information to next layer, and the next one is to next one, like up to down, top to bottom approach is there. And when it comes to the receiver to sender, we can say bottom to up approach is there. So this all can be in a manageable form only, right? And last one, troubleshoot and update to handle per layer. This is also an advantage or objective of OSI model. Now the first one, as we said, application layer, it is considered as layer number 7, because we consider from the lowest layer, bottom to up approach. If we consider physical layer, can be the first one. So here the layer number 7, that is application layer. Application layer means what? Provides the major purpose. Okay, the major purpose of application layer is to provide services directly to the user and application. Okay, and second point, you can say it acts as an interface between the user and the network, right? And it is responsible for network related application services like SMTP, FTP, or HTTP. Okay, here maybe I'm using the web browser, so by using HTTP I'm asking some message or asking some information, right? So here you can say the responsibility of network related application services. These are the different services that application layer uses for communication. These are the different protocols. So what happens? Identify communication partner. Application layer, it identifies the communication partner. It provides user authentication. Also it enables files, prints and messages across over the network. And the example protocols which are highlighted here are HTTP, FTP, SMTP, DNS and SNMP. These are the different protocols which are highlighted or which are doing the work of application layer. Whatever the messages the application layer having, or whatever the users information are there, it is passing to the network layer by using, or to the network, not the network layer, to the network by using all these different protocols. Okay, so the application layer directly to the user and the application, and these are the important points for application layer. Next is presentation layer. So presentation layer ensure that the data is in a readable format. Okay, whatever the information is passed from application layer to the presentation layer, the information should be in a readable format, and also it acts as a translator between the application layer and, you can say that, application layer, a translator between the application layer and session layer, you can say, right? And the network format. So the network format, or we can say here whatever the encryption decryption processes happening for the translation matter, that is done by whom? From the presentation layer. Whatever the information I am getting, the information will be encrypted or decrypted in this presentation layer. Okay, and then after it is moving to the next session layer, right? Now the functions of this presentation layer is, it will convert data from one format to another. As a part of encryption, it is converting the information or the data from one format to another. Then after, as we said, yes, it will encrypt or decrypt the information. It will encrypt or decrypt the information by using SSL or TCL, or it is this secure socket layer is helping for this secure data. While doing encryption and decryption, the secure data should be transferred, right, for the by using SSL or TCL. This is happening. Compression, we can say, reduce the data size for efficient transmission. So here, when it is actually encrypting or decrypting the data, it is very important to take care or giving importance to reduce the data size of efficient transmission. Otherwise, there are chances that there may loss of data may happen. Okay, packet loss may happen. So for that purpose, it should reduce the, or the size of data may impact. So for that purpose, you have to reduce, or this thing is happening in presentation layer. For the examples are whatever the protocols which are activated here, or whatever the encryption methods are there, you can say that JPEG, MP3, MPEG, GIF, SSL, these all are the different formats which are happening during encryption or decryption method in presentation layer. Moving to the next session, that is session layer. So information was passed to the session layer. So here what happened, it will manage the connections between two communicating devices. Okay, and then a session represents a single conversation between two applications. Then after, what happened, what are the functions of this session layer? You can say that it establishes session between the system. It establishes the system between the system, sessions between the system, maintain the session during communication, then terminate the session after completion, and then synchronization of data is also happening in session layer. Okay, so again, remember what discussing about the layers in OSI model, right? In that, the first one we said the application layer, then we are in session layer. Okay, so remember, this is the fifth layer. This is the fifth, the communication. It manage and control the communication between two computers or two devices. And here the major thing that we have to remember is, it establish the connection, it maintain the connection, it synchronize the data, and finally it will terminate from the connection. Okay, so here if we take an example, when you log into the website or to join an online video call, the session layer keep your connection activate until you log out or end the call. So this is done by session layer. Okay, now moving to the next. Fourth one is transport layer, which is very important layer. Okay, so transport layer, it is providing the end-to-end delivery of complete message between devices. It is giving end-to-end delivery of complete message. Okay, and it ensures, this is very important point, that it ensures the reliability and error free data transfer, reliability and error free data transfer. Okay, so here the transport layer is the fourth layer of the OSI model. It is responsible for reliable and error free data transfer between computers over a network. Okay, so now what are the major functions which is used for these purposes? So here we can say segmentation is one of the function. Okay, so segmentation means what? Breaks large data into smaller part called segments for the transmission. Then after reassembly means what? Combine the received segment back into the original message. So segmentation and reassembling both are very important when it comes to transport layer, because here we are talking about sender to receiver and receiver to sender approach, right? So when it comes to sender to receiver, segmentation is happening, and when it comes to the receiver end, we can say the reassembling is also happening on that portion. Then after error control, we can say that it will check for errors in data and request retransmission if it is needed. Okay, so here error control means it will detect and retransmitted lost or corrupted segments if it is needed. Okay, if error is happening, it will detect, it will retransmit the lost information. Then after flow control, you can say that it prevents senders, it will prevent the senders information, or else we can say that it ensures that the sender does not send data faster than the receiver can handle. This is very important. Okay, if the sender is sending information very fast that receiver cannot handle, then the meaning is what? The packet this segments can be lost, or the packets can be lost, information can be lost, right? So it should not happen. So this is also done by transport layer. Then after the connection control, you can say that it can provide connection oriented communication or connection less communication. So here connection control is also done by transport layer, whether the connection oriented or connection less services is there, means TCP or UDP, which protocol is activated here, that is also in transport layer. Okay, so again I'm giving 30 seconds you to please go through the content which we have discussed till transport layer, application, presentation, session, transport. These four layers we have discussed. Please go through. Okay, so here you can say that the protocols which are activated, or the protocol which are ensuring that the error control, flow control, connection control, or all these processes, we can say the TCP for the reliable communication, and for the unreliable communication or the packet, if it is a losing or anything is happening, you can say that it is because of UDP. Okay, so the OSI model, when it comes to OSI model, the first four layers are considered as host layer, and in that area the data are transferred in the form of data in first three, means application, presentation and session. And when it comes to the transport, as we people said that it is adding end-to-end connection and reliability. So in this portion, in a segment, okay, the data is moving in the form of segments, or break that large messages into the smaller parts, so that is known as segment. Now when it comes to the next three, that is in media layer, when it comes to the next layer, you can say that transport layer. After transport layer, network layer is there. Okay, network layer. So this is the third layer. This is considered as the third layer. So it handles logical addressing and routing of data packets. It determines the best path for data to travel across the network. Okay, and the functions are logical addressing, routing, packet forwarding, fragmentation, and reassembly. Okay, so these are the different functions. Okay, so again I repeat, the network layer, it is the third layer of OSI model. It is responsible for delivering the data. Okay, it is responsible for delivering the data packet from one computer to another across different network. And when it comes to the major functions, you can say logical addressing means assign unique IP address to device so that the data know where to go. This is what logical address says. Routing means choose the best path for data to travel through the network using the router, or else we can say the optimal path for data transmission. When it comes to packet forwarding, we can say move data packets from one network to the another, or from source to destination, that is packet forwarding. Then we can say in the previous we talk about segmentation and reassembly. So here we can say fragmentation and reassembly. So fragmentation means again break the data into or smaller packets for transmission and reassemble them when it reach to the destination. Okay, then after the last one we can say here error handling. Error handling is also a part of network layer only. So here detect and report the delivery problem, whatever the problems is identified by the network layer. Okay, while transferring the or while the transmission of a data, that can be report or delivered. That information, that problem will be report to the next part. Okay, next layer. This is also done by the network layer. So here you can say that the protocols which are activated on this session are IP, ICMP, IPsec, or IGMP. These all are the different protocols which are activated. Now here the we can say the major devices which are connected to this network are this one routers or switches can be considered. Okay, in this portion. Now moving to the next, which is very important, again a data link layer, which is very important layer in OSI model. Okay, so this data link layer, you can say it is the second layer of OSI model. It is responsible for reliable transfer of data between two devices on the same network, right? And what it is actually doing, we can say that it ensures the error-free transmission of data frame. Okay, and it organize raw bit from the physical layer into frame, or else as we are talking to sender to the receiver, so whatever the packets it is getting from the sender or from the network layer, it moves the packet to the into the form of frames. Okay, to the form of frames, we can say. So what is frames? Okay, what is frames? We can say that framing means converting data packets from network layer into frames for transmission. It is actually giving different framing, giving header and trailer to the information which we are getting from physical layer, adding header and trailer. And when it moves to the network layer, that header and trailers are actually going to the network, and it is in the form of packets or segment. Accordingly it is moving on. And when it comes to the packet, when the packets are coming to the frame, means again the header trailer part will be there because of some security reasons, right? So that will be moved when it comes to the physical layer. Okay, so here framing means the convert data packets from network layer into frames for transmission. Then the second one is error detection and correction. Error detection and correction means check from transmission errors using CRC, cyclic redundancy check, which is very important part. Okay, very important when it comes to error detection and correction. So here we can say check for errors in transmitted data and fix them if possible. That is actually done from error detection and correction. Flow control means ensures a smooth data transfer so that the sender does not overload the receiver. Okay, flow control. The importance of flow control is very clear, that it ensures the smooth data transfer so that the sender does not overload the receiver. Okay, sender is transmitting the information again and again, and the receiver couldn't handle the information. Then what happened? The information may lose. So that should not happen. That was ensured from flow control. Then after physical addressing, or you can say MAC addressing is there. So using MAC address, or else you can say MAC address means what? Unique hardware addresses. Unique hardware addresses to identify device on the local network. Okay, it will identify the device on the local network. Okay, and then you can say that access control is also one of the function of data link layer. Access control means what? Decide which device can use the network at a given time to avoid the collision. Okay, which network to be used to avoid the collision. That is also done by data link layer while moving information to network layer. When we are moving information to network layer, it is the responsibility of the data link layer to ensure the access control, means decide which device can use the network at a given time to avoid the collision. So here the protocols which are highlighted here, we can say Ethernet PPP, point to point protocol. PPP means point to point protocol. HDLC, frame relay. These are all are the different protocols which are highlighted in data link layer, and the devices are switches or bridges can be considered. And finally the physical layer. Okay, the physical layer, which is very important when it comes to OSI model. So physical layer, we can say this is the first or the lowest layer. This is the first or the lowest layer of OSI model. It deals with actual physical connection. Okay, it is dealing with actual physical connection between devices and transmission of raw data in the form of bits, that is zeros and ones. Or else in short we can say it deals with transmission of a raw bit over a physical medium. Okay, so here it defines electrical, mechanical and functional specification for the connection. Okay, physical layer means it is actually defining electrical, mechanical and functional specification for the connection. So what are the functions? So here we can say transmission of bits. Functions, the first function we can say transmission of bits, send data as electrical signals, light pulses or radio waves. Okay, this is one of the function. Or else define voltage level, signal rate or data rate, that is a function of physical layer. Okay, then after we can talk about the hardware component. It includes cables, switches, hubs and network interface cards. Okay, so this is also a function. Then after data rate control, you can say decide how fast the data should be sent. Okay, then here the physical when it comes to this physical layer, you can say the physical topology is also one of the very important function in this area. Define how devices are connected. Okay, how the devices are connected. So when it comes to the topology, there are so many topologies which we have already discussed in our lectures. Okay, so that is we can say star topology, bus topology, ring topology, mesh topology. All these are the different topologies which are there in physical topology. Okay, so this actually decide how devices are connected, whether it is in the form of bus or in a form of star or in a form of mesh. Okay, so this can be also considered. Then after transmission mode, so the transmission mode, we can say it determines the direction of the data flow. Okay, it actually determines the direction of data flow, means whether it is a simplex or it is a half duplex or it is a full duplex. So this is also a function of physical layer. Okay, so I haven't mentioned all these portions in this presentation. So remember, the first function what I told here is transmission of bit. That means already it is written, define voltage level, signal rate and data transfer. Okay, hardware components, like we have discussed, specifies cables, connectors and interfaces. Data rate control, decide how fast the data should be sent. Physical topologies and transmission media, which is again an important part. Physical topology, define how devices are connected, whether in the form of star, bus or mesh topology, etc. And transmission control or transmission mode means determines the direction of data flow in the form of simplex, half duplex or full duplex. Okay, and here the examples of this area is Ethernet cables, fiber optical cables, hubs, repeaters, NIC cards, Wi-Fi signals, modems, etc. can be considered as a part of OSI model layer 1. Okay, so please go through the whole content which is added in this portion, which is very important. Okay, now the working of OSI model, which is very important. The figure is very important. It shows the adjacent communication between each layers. Okay, here is an internal subnet protocol which is helpful for the communication purposes. Okay, and this is a communication subnet, this is a communication subnet boundary. Okay, in this portion what happened, physical layer host router protocol is activated. Here it is about data link layer host router protocol, and here it is network layer host router protocol. So here we can say that host A and B. So here when the information is actually transferring from sender to receiver, so sender is actually there in the application, then presentation accordingly it comes to the next presentation, next physical to the application, till the application. So this is actually very important figure. Remember, it is very important, you have to draw this figure when it comes to the explanation of OSI model. Here whatever the things we have discussed throughout today's lecture, all the content I have extracted here. Okay, physical layer means raw bit of data. What it actually defines the format of data on the network. It defines physical path that data will take. It transmit the information, it maintain the connection, it encrypt the data, and finally the human interaction happens on this portion. Okay, so go through this portion and tell me if there is any doubt. Now this is again a very important portion, comparison between OSI and TCP IP model, which is very important. Okay, this also you can expect for 7 marks. Okay, so here TCP IP model is a foundational framework for enabling communication between devices over interconnected network. Okay, and it ensures reliable data transmission by breaking information into packets, route them to their destination and reassemble them accurately. The model consists of 4 layers. Okay, so again whatever we have discussed in OSI model, so here application layer, it is doing all the work of application, presentation and session. Transport layer, the same work. Internet, the same work. Network access layer is doing the work of data link layer and physical layer. So whatever we learn in OSI model, the same thing will be applied in TCP IP model also. And we consider that this OSI model is a conceptual model, and this one is a practical model. This is actually considered as a practical model, and this is a theoretical or a conceptual model. Okay, so whatever the things we learn in this portion, we have extracted to here also. So please go through this presentation. If you have any doubt in this portion, you should ask. Okay, whatever we have learned in this area, that only we have added here. Moving, so here remember, this is again very important. Developed, it was developed by it is developed by ISO, International Organization for Standardization, and TCP was developed by DoD, Department of Defense. It was developed in year 1984 and it was developed in year 1970 when it comes to the ARPANET project. Okay, means ARPANET came in 1969, right? So accordingly it came. Purpose is conceptual framework for understanding and designing the network system, and obviously as we said it is a practical model. It was having 7 layer, it was having 4 layer. These are the layers which is there in OSI model, and these are the 4 layers which are there in TCP. It actually give importance to the vertical approach, which is very important, one after the next. After physical only data will come, after data only the network will come, like that. Okay, and it is actually flexible layering. Okay, it is giving importance to the horizontal approach. When it comes to the developed before, after, develop, okay, before or after. So here we can say this OSI model was developed after the internet. Okay, internet actually came in, as we said, 1991 or 1990s it came, right? So before that, this TCP IP model was there, because ARPANET, along with the ARPANET project, this TCP IP was there. So we can say this was the initial one, and this actually came after the internet invention. Here, session and presentation layer present as a separate layer, but here it is actually along with the application layer. Now application layer, here it was application, presentation, session, the same point is repeated here only, don't worry. Then after, here when it comes to the application, single handle, okay, it was singly handled or single handle, means all the 3 functions are handled by the application layer. Okay, then after, the network layer protocol defines routing conceptually, and here it uses internet protocol for routing. Okay, it uses internet protocol for routing. Then after, we can say that data link and physical layer. So here, separate layer for framing, error control and transmission. Here it is again a single handed, right? It means the network access layer only doing the work of framing, error control, transmission. Addressing schemes are also like here, both MAC and IP addresses are there, or else logical address, only primary logical IP address is there. Yeah, logical address is there. Error handling, it was performed by data link layer and transport layer, and here it was done by TCP, transmission control protocol, and internet control message, ICMP. Okay, ICMP. So and then after, we'll move to the next, that is internet control message protocol, ICMP, internet control message protocol. Okay, then after, flow control managed by the transport layer. Here also it is about the transport layer, but by the TCP. Okay, then after, protocol, we can say protocol independent, means generic model will be there, and in this area protocol specific is there. Okay, and when it comes to the communication, layer to layer communication will be there, and when it comes to this area, TCP IP, we can say end to end communication over internet. Reliable communication means it ensures through transport layer and goes through TCP. When it comes to error detection, data link, transport layer, it is about ICMP and TCP. Okay, address used, physical and logical, it is about IP. Advantages, you can say clear layer separations, standardized model, and also help in learning and designing. It is about the practical and robust model, work efficiently in real network, and it is a foundation of internet. It is about the, we can say, the disadvantage. So here it is about the complex and theoretical model, where it actually we can say lack clear distinction between the network. This is an disadvantage in TCP. There is no separation between presentation or session layer. Now the last point, we can say the example not directly implemented, but yes, this is about the internet architecture starts from this area only. Okay, so these are the important points which we have covered in OSI and TCP IP model. So please make sure this is very important 7-marker question you can expect when it comes to the comparison between OSI and TCP IP model. Okay, this is very important. Okay, so here we are winding up the session. So we can say that what we learn. So total 16 questions I have added accordingly that today's content. Okay, so here what are the main uses of computer network? Already you people know the answer. Then after PAN, LAN, MAN, WAN, Internet, ARPANET, NSF net, Internet architecture, okay, protocol layer, connection oriented and connectionless service, service primitive, service and protocol relationship between, okay, service and protocol. Then the purpose of OSI reference model, then name the 7 layers of OSI model. What are the main layers in TCP IP reference model? So these are the different questions that you can expect from this unit number 1. Now these are the long questions that you can expect from unit 1. So this is very important. You have to focus on this, both the area, short as well as long. Okay, and when it comes to long, explain the different uses of computer network in business, home and mobile environment. Discuss the type of computer network. Obviously we learn with the help of diagram only, we came to know the differences or the importance of this. Then after write a detailed note on ARPANET and NSFNet. So we have enough information about both the concept, right? Explain the difference between connection oriented and connectionless services with the suitable examples, that also we have covered. OSI model in detail, describe the functions of each layer. Explain the TCP IP model in detail with its layer and functions. Mention difference between OSI and TCP IP model. So again I am repeating, please go through this session again. Okay, try to clear the concept about whatever things we have learned today or whatever things we have discussed today. The questions which I kept here, this all are obviously there should be minimum 2 to 3 pages you have to write, or else you can say minimum 14 to 15 important points should be there when you are attempting these questions. Okay, so again I'm reminding, please try to write the questions as well as the answers for your better understanding. Okay, so here the next topic. Okay, next topic, as we said, unit number 2, which we can revision part because it is not possible